All right, so as promised, I am doing a live session on quadratic equations. This is section 1.4 in two different parts. Currently nobody's on, but I'm going to record this anyway so that you have it. So yeah, I'm going to get this started. And hopefully this will be helpful. Quadratic equations are usually very difficult for people, especially the techniques that we're doing this week. Yeah, hopefully this helps. So this is part one. So section 1.4 covers solving by factoring. So that's one of the reasons why you really need to be able to factor. Solving by extracting square roots. So that's one of the reasons why you need to know how to do square roots. Solving by completing the square. That's probably the most difficult method that we use. And then solving by using the quadratic formula, which is probably everybody's favorite. And then lastly, using quadratic equations to model and solve real-life problems. And we are actually going to revisit that when we get to week 5 and talk about polynomials. So what is a quadratic equation? A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. So the key here, it's not just, it doesn't have to be exactly in the form. The key is that the highest exponent is 2. Or highest exponent on the variable. And that's what makes it quadratic. Now you have to be careful because things can be quadratic if before and just not be simplified all the way. So we could have something like x times x plus 2 equals 5. That is quadratic because when you distribute, you get x squared plus 2x equals 5. So you have to look at it after you do any distributing to determine whether it's quadratic or not. Now, the x squared plus 2x equals 5 is not in the form that we're given, but if I subtract 5 from both sides, then it is. So that's why we say it can be written in that form. And then because the highest exponent is 2, this is called a second degree polynomial equation because the degree of the polynomial is 2. And we talked about degree briefly in P.3. Okay, so because there are 4 different methods for solving quadratic equations, a lot of people get confused on which one they should use. And so I've made this little chart. And I'm going to zoom in so that we can see it a little better. So you've got a quadratic, and you need to have it in some form in order to determine which one you're going to do. So if you're trying to get vertex form, which is something we will, let me get my pen, something you will learn about in, maybe it won't let me do my pen. Okay, I can't be zoomed in and do my pen. But that is something that you'll learn about in 3.1. Then you would complete the square. Although we will be completing the square in this section so you can learn how. But we usually only use it to get vertex form or use it when you get into pre-calculus and calculus. It's handy. Otherwise, if you're trying to solve, then you want to check the form that it's in to determine which method is good. So the first form, if we have ax squared plus bx equals 0, so there's no constant term. That is something that you can factor, so you want to factor that. Second form is ax squared plus c equals 0, so there's no term, there's no bx term is gone. To do that, you want to extract square roots. And then if you have all 3 terms, then you need to check something that's called the discriminant to determine if it's factorable or not. So I'm going to zoom out. The discriminant is b squared minus 4ac, and you plug in the numbers from the form ax squared plus bx plus c. Plug in those constants and the coefficients, and then figure out, you follow the order of operations to check the discriminant. So if the discriminant is a perfect square, which means you can take the square root of it, then that means you can factor this. And in fact, I would recommend factoring because it is usually faster. If it's not something you can take the square root of, then use the quadratic formula. So Hopefully this will help you determine which method you should use when you are solving. And so maybe this out would be helpful, whatever you need to do. So we're going to start by solving by factoring. So brain part. So in section P.1, we talked about some special properties of real numbers. And we had the fact that if you add or subtract 0, you're left with the same number. If you multiply by 0, you get 0. 0 divided by a number is 0, or a number divided by 0 is undefined. And then we had this last one, zero factor property, where if you had two numbers that multiply to 0, then at least one of them needs to be 0, because the only way for them to multiply to 0 is if one of them is 0. It doesn't mean that only one, they could both be 0, or one of them could be 0. So at least one must be 0. So that zero factor property, that is the principle that we're going to use to solve, because we're going to factor something. And if you recall, if we have a quadratic, I will just make one up. Let's see, let's make that, yeah, that should be there. That will factor. If we have x squared plus 3x plus 2, this factors to x plus 2, x plus 1. So we get two factors. So you can think of that as your a and then your b, and they're multiplied together. So if this was something that was equal to 0, then we now have a times b equal to 0, which means a is equal to 0 or b is equal to 0, which, oops, I wrote a equals b. A is equal to 0. And if we think a is, we look at what actually a is, that gives us x plus 2 equals 0, x plus 1 equals 0, and then you would solve those for x. So that's the zero factor property, and we're going to use that to solve by factoring. And actually, I just almost solved this entire thing by factoring. The final answers would be -2 and -1 when you actually solve those linear equations. But that is the principle here when we're solving. You're going to factor it and then set each variable factor to 0. So the steps for solving by factoring. We have to first put the equation in standard form. So that means you have to have everything on one side and have it equal to 0. So you can't start factoring until it's equal to 0. Then you need to factor the equation completely. So that means factoring off the GCF before you factor everything else. Once you've done that, you want to use the zero factor property. So that means you set each factor equal to 0. So when we have something factored, we're going to have the two sets of parentheses equal to 0. And then you set each of them equal to 0. That's the zero factor property. And then you solve those equations to get x equals a number. And that's the whole process. It's really not so bad. The hardest part is factoring, and the better you are at factoring, the quicker you are at factoring, the faster that this process will be. So I have several examples. So this first example, we're going to solve this by factoring. So this is in the form, I had that chart. If I go back to that chart, this is in the form ax squared plus bx equals 0, the top one there, which means that we can factor. Because we have an x squared term and an x term, but we don't have the constant. The form is ax squared plus bx equals 0. And if you kind of want to see the form, so that would mean that a is equal to 8 and b is -2, if you want to compare that to the form. You don't really need to know that for factoring this, but just so you can see how it compares. So solve this, your first step is, because it's already in standard form, it's already equal to 0, so now you need to factor. And we need to factor out the GCF when we have something like this, because it's not a trinomial, so it's not going to be parenthesis times parenthesis. this is going to be where you need to factor out the GCF, and then you see what you have left over. So if we look at, we have 8x squared minus 2x. So between 8 and 2, I can factor out a 2, and then there's an x in both of those. So I can factor out a 2x. And then I'm going to divide that out of what I started with. So 8 divided by 2 is 4. And then x squared divided by x is x. And then 2x divided by 2x is 1. So I'm not going to show all the steps for factoring. I'm going to be doing it mentally because I want to focus on the solving process rather than the factoring process. And if you need to review factoring, I do have that factoring video from T.4 way back from week 1. Okay, so now I have 2x times 4x minus 1 equals 0, and now we're going to use the zero factor property. And that is where you set each factor equal to 0. So I set 2x equals 0, and then 4x minus 1 equal to 0. So the 4x minus 1 that's one of the sets of parentheses, so that's equal to 0. The 2x is in front of it, that's still multiplied, so that's the other part of it. And then I need to solve. So 2x equal to 0, I would divide both sides by 2. 0 divided by 2 is still 0, so I got x equals 0. And then 4x minus 1 equals 0. I add 1 to both sides. So you got 4x equals 1. And then when I divide both sides by 4, I get x equals 1/4. So my two answers are x equals 0 and x equals 1/4. So when you're solving a quadratic equation, you're going to have two answers because it's x squared. You could potentially get one answer if it's the same number, or you could get 0 answers if it turns out to involve like a negative, or you have to do complex numbers, but you're never going to have more than 2 answers, and 2 answers is the most common thing you're going to get. So you know you're done when you have 2 values for x. Okay, so I know that somebody, Veronica, I had heard somebody join while I was going through this. Do you have any questions on that example?
No questions, thank you.
Okay, so let's take a look at my second example here. Okay, so this one is also in standard form. If you get something that's not in standard form, you just have to follow the steps to distribute and then move everything on one side. So I got 2x squared plus 12x plus 18 equals 0. So we want to factor. That involves first factoring out the greatest common factor. So I can divide 2 out of everything there. So that would leave me with, once I divide everything by 2, I would get an x squared plus 6x plus 9 equals 0. So now that I've factored out the greatest common factor, now I want to factor what I have inside parentheses, the x squared plus 6x plus 9. So that gives me x plus 3 and x plus 3 equals 0. So that's one of those special factors. And then we set each factor equal to 0. So if that 2 in front, we don't have to set that equal to 0 because that doesn't have a variable. So you only set the things that have variables equal to 0. So we have x plus 3 equal to 0. And then you can see we have x plus 3 again. That is the same thing. So we only really get one equation out from this. X plus 3 equals 0. And then we solve by subtracting 3 from both sides. We get x equals -3. So this is one of the situations where you get one solution. And that's because when we factored, we ended up with something that was identical for each factor. So that second factor doesn't add anything to the equation. Instead of writing it the way that I did, that step where I did x plus 3, you could write it as 2 times x plus 3 squared equal to 0. Now, if you have that, then you can then say, okay, x plus 3 squared equal to 0, because if you divided both sides by that 2 in front, 0 divided by 2 is 0, so that's basically irrelevant. And then what we have at this point is something that can take square roots on, which is the next method. And the way that works is that you take the square root of both sides. So you would take the square root of something squared, which cancels that out. And then you would take the square root of the right side. And when you take the square root, you get a plus or minus. And we have a square root of 0, but square root of 0 is still 0, and 0 doesn't have plus or minus. So that gets you to the same answer. If x plus 3 equals 0, and then that would give you x equals negative 3. So this is a problem that you could solve by factoring. That's the method in the blue. Or if you rewrote it the way I did in purple, you can use the method where you take square roots, which is the next method that I'm going to work through. So some problems can be done either way. Any questions on that example? Okay. Feel free to pop in if you have any questions. Okay, so this method of taking square roots, or also called extracting square roots. I don't like the term extracting because it sounds like you're kind of like when you're extracting something from the earth or removing something from the earth. We're not actually removing square roots. We're actually we're doing a square root. So that's why I call it taking square roots. But the book calls it extracting. So to understand this method, we're going back to section P.2. So this is a chart from P.2 when we're talking about square roots. And so let's say you're taking the square root of a number. If you're taking the square root of a positive number, which is the first row, and square roots means the n is even. So we're really only caring about rows where n is even because those are square roots. Square roots have the n is 2 basically. So if we're taking the square root of a positive, then we get a positive and a negative answer. So we can rewrite this as a plus or minus and then whatever that square root is of that number. Because you can get a positive number out and a negative number out. However, if you're trying to take the square root of something that is negative, then there are no real roots because we can't take the square root of a negative. If you try to do that on your calculator, you're going to get an error unless you have a really fancy calculator. And so then we'd say there are no real solutions when you're taking square roots. Now this is just temporary for 1.4 because section 1.5 will tell you how to do this. Section 1.5, which is on complex numbers. This allows us to take square roots of negatives. And the ability to do this actually is needed when you go into some engineering fields. So because I'm just covering section 1.4, I'm not going to cover that part, but when you get to 1.5, it will be the same process. And it's going to be very similar to how we simplify things with radicals. We just now have this, instead of having a negative, you pull the negative out and it becomes an I. So, but it's very similar to what you've done before. So everything that I do in 1.4, if I get a negative in the square root, then we're going to just say that it's not a real number. There are no real solutions. So the steps for extracting square roots, there's basically just two steps. So first you have to put the equation in the form u squared equals d. So my example 2 previously, when I demonstrated that ability to take square roots, we had x plus 3 squared equals 0. So that is in the form u squared equals d if u is x plus 3. So it's just something squared equals, and it could equal a number. In this case, our number is 0. So you don't have to have it equal 0. It could equal any number. It just has to be something squared equals a number. And then you just take the square root of both sides, and then that's where you get this plus or minus square root of whatever you ended up with. And that's how I got plus or minus square root of 0, which then just gives me 0 because 0 doesn't have a square root, or it is 0. It doesn't have two answers. So I have several examples to go through this. I think I have like 3 or 4 examples. There's 2 on this one because these are quicker. Okay, so the first one is very simple. We have x squared equals 144. So this is in our form, something squared equals a number. So I'm going to just rewrite it so that I can show the square root steps. So you're taking the square root of both sides. And then to help you remember the plus or minus, maybe you want to write the plus or minus in there. So the square root of something squared, that cancels and you're left with just x. And then I need to have my plus or minus. And then the square root of 144 is 12. So we can split this up. This plus or minus means that we have a positive answer and a negative answer. So this that we have x equals 12 and x equals negative 12. And so we do have 2 answers here, just like we should with something that's squared. And they're just 12 and negative 12. You could keep it in the plus or minus 12 form. That's easier to work with if that's as far as you need to go. You have x equals plus or minus a number. That's completely fine. There will be some cases where you are going to have to split it up in 2 separate equations. So I recommend always splitting it up as I did here, just so that you always have that, especially when you start doing things with the quadratic formula, which I'm going to cover tomorrow's session. You'll have to split it up into 2 separate equations. So you're going to take the square root, you're going to get a plus or minus something, and then write 2 separate equations and solve for x. In this case, they're already solved. Now moving to the second example here, I have 9x squared equals 36. So I'm going to just rewrite this. Now the best way to use the square root property here and to take square roots is to divide both sides by 9, so you just have that square part by itself. So we're going to divide everything by 9. And this gives us x squared, and 36 divided by 9 is 4. So now you take the square root of both sides. I get x equals, and then I'm going to have plus or minus, and then the square root of 4 is 2. So if I write this will give me x equals 2, x equals negative 2. And those are my 2 solutions. Are there any questions on any of these 2 examples? Okay. Now this one is similar to that example 2 I did when we were factoring. Because now instead of just x squared, we have something in parentheses squared equals 18. So I'm going to rewrite this so that I can show I'm going to take the square root of both sides because I have something squared equals a number. So the square and the square root cancel. and we have x minus 4, and then I have plus or minus, and the square root of 18 doesn't come out to a whole number. So this is where we have to go back to p.2 and simplifying radicals. So we haven't had to do that in a couple weeks. So if you need a refresher, I do have a video on that one. And we have to simplify this radical. So square root of 19, or square root of 18 is 9 times 2. So I can rewrite this as plus or minus the square root of 9 times the square root of 2. And the square root of 9 is 3. So that's x minus 4 equals plus or minus 3 times the square root of 2. Now this is one where you have to write it in two separate equations because in order to solve for x, it can get a little confusing. So we could solve in this case by adding 4 to both sides. But the 4 is not a like term with 3 times the square root of 2, so you would write it separately. And we usually would put that first and then the plus or minus part. So we would write it as 4, or x equals 4 plus or minus 3 times the square root of 2. Now that often gets confusing, especially if you have a plus or minus a whole number there, but you have something else that you need to add. So I don't recommend doing that. What I recommend doing is writing the two separate equations. X minus 4 equals 3 times the square root of 2, and x minus 4 equals negative 3 times the square root of 2. And then add 4 to both sides. And so that would be 4 plus 3 times the square root of 2. And x equals 4 minus 3 times the square root of 2. And I do that because if it was something that didn't have a square root, whenever you have a plus or minus, you can't add numbers to something with a plus or minus. You have to separate the plus or minus first before you can add or combine them, basically. And so if you just get in a habit of always splitting that plus and minus up before you actually do any addition, that will prevent you from having problems later on down the road. Are there questions on this example? Okay. Example 3 here, and this is actually the last example that I have. And so then there's, we open time for questions after this one. So what happens when we have something squared equals something else squared? Like this case. We have square root of x plus 5 squared equals the square, or the x plus 4, that squared. So if you're taking square roots, we always had to add a plus or minus. We still need to do that. We're just going to pick one of the sides to add the plus or minus to when we take the square root. So I'm going to first rewrite this, just write it again. And because everything I've been doing, I've been having like the thing with the x on the left, I'm going to do the same thing here. So we're going to take the square root of both sides. And then we're going to cancel it out on the left. And then I'm going to put the plus or minus on the right. And then have x plus 4. So I've got plus or minus parenthesis x plus 4. I have to have the parentheses there because the minus will apply to everything, the x and the 4. And so we'd have to distribute that. And so this is one of those cases where, oops, that shouldn't say squared on the left. Should be just x plus 5. But this is one of those cases where you have to write your equation separately because of the fact that you're going to have to distribute before you can minus 5. So we're going to write two equations here. X plus 5 equals, and then the positive version, x plus 4. And then x plus 5 equals negative x plus 4. And now I need to solve each of these for x. So on the left, I'm going to subtract x from both sides. And I get x minus x, which is 0, and you get 5 equals 4. So you don't get a solution from that one. Now on the right, I need to distribute that negative parentheses first. So I have x plus 5 equals negative x minus 4. So now I'm going to add x to both sides. That gives me 2x plus 5 equals negative 4. Now I'm going to subtract 5 from both sides, which gives me 2x equals negative 9. And then when you divide sides by 2, you get x equals negative 9 halves. So we got only one solution from this problem, and it's negative 9 halves. And that came from the negative version of the square root. So that's why it's important to have the plus or minus. You can't just ignore the plus or minus and just have the positive version on both sides, because that would show that there's no solution, because we've got 5 equals 4, which is contradiction, no solution. But because of the plus or minus, we have to also consider the fact it might be negative, and that's what gave us a solution, negative 9 over 2. So it's really important to have that plus or minus, because you might miss solutions. And it's really important to show every step so that you don't make any errors with your signs. So, are there any questions on this last example? Okay. So, that's the last example that I have for you guys. And tomorrow at 1 p.m. is going to be the next live session. That is going to be part 2, where we're going to cover completing the square, which is going to involve taking square roots like we just did. And then the quadratic formula, which is going to also involve taking square roots and simplifying radicals. So it's going to involve the same sort of skills that we just did today. And it's going to involve factorings, basically. Factorings and everything. You're going to be factoring, you're going to be taking square roots, and simplifying radicals. So it's like everything we did today on steroids, if you want to think about it that way. So hopefully I see you then, and I hope you guys have a great night.